Hey, it's November 30th. Some important events in history on this date. In 1487, the München Reinheitsgebot. In 1495, the Viborg explosion. In 1939, the start of the Winter War. And in 2015, the Rumprun unikernel video series Chapter 3. So, this one was originally supposed to be about the internals of the Rumprun unikernel. But then I realized we hadn't discussed an important topic, debugging applications, which are running on the Rumprun unikernel. And since debugging is something that everyone who runs applications might run into or have the need for, and internals are something that only people who are interested in digging in the internals have the need for, let's discuss the debugging first. And more specifically, I'll just concentrate on GDB in this chapter, how to use GDB against the Rumprun unikernel. And more specifically, how to use GDB against the Rumprun unikernel running as a QEMU guest. So, before you start breaking out GDB, you should, of course, try some simpler techniques, like if your application works in user space at all. I mean, it's usually good to make sure that it actually works at all before you start deploying it. The second thing would be to check if it works. I mean, if you check if it works in user space on Linux, for example, the second step would be to check that it works in user space on NetBSD. So it's not a case of a portable program being portable between Ubuntu and Red Hat, as opposed to actually being portable. If you don't happen to have a NetBSD installation, check out this URL, which hosts a nifty Python tool for installing NetBSD as a virtual machine. So you essentially give this Python script a distribution URL, and it downloads and installs a NetBSD on a virtual machine image for you, or actually under QEMU for you. So you can, get a quick. That's a quick way to install a NetBSD for testing if you want to be able to do it. Okay, but anyway, let's get down to GDB. So again, to demonstrate, we'll just use a hello world-ish program and demonstrate with that. So hello, I'll just print something non-constant so that GCC doesn't optimize the printf call to puts if we, might want to put a breakpoint to the printf call later, so we'll be able to do it. Of course, you can also give an argument to GCC to say that, hey, don't optimize this, but it's difficult to remember to do that, so this is easier. Okay, so first step, let's see if we can run it in use, I think it works. I managed to write hello world correctly. So how you'd normally debug this is either you run the program, then you attach GDB to the process, or you run the program under GDB. And the advantage of this run the program under GDB method is that then you get to decide exactly where you break into the application. I mean, this is such a short-lived application that good luck trying to attach to it if you're not running the program entirely from under GDB. Oh, you put a breakpoint to main and then you run it, and now you can start debugging. So how do we translate this to Rumprun? Well, that's all this episode is about. So we'll run tmux because I need two windows. Let's split it. Let's actually try to do it correctly. Let's make this other one a bit smaller because it doesn't need to be so big. We'll compile it as usual, except if we type the compiler name correctly, it's better. Okay, and we bake it as usual. and then how do we run it? So well, essentially you run QEMU and then you attach an independent GDB instance to the QEMU. Actually, you run QEMU so that it has, or it starts a GDB server and then GDB attaches to the GDB server. So in practice it means that you run it. By the way, you should use QEMU when debugging. If you use KVM, in my experience it doesn't work that well for debugging. I'm not sure exactly why, but if you know, let me know. I'll just keep using QEMU meanwhile because it worked great for me. So which is just, I mean, KVM is just, so KVM without the KVM acceleration, if that makes any sense. Okay, we tell it to start a GDB server on port 1234 and we pause the domain at start. So instead of QEMU starting to execute the guest, it actually just sets it up, opens this port and then pauses and waits for a GDB connection. So what happens in this case? We do this, which is essentially the same as this, or is the same as this. And now we're connected to the remote GDB, and theoretically we should, well, actually let's put a breakpoint first. Let's put a breakpoint in main. I'll get to the reason why, but the main is Rumprun main1 instead of main. Yeah, so now we should be able to continue and hit the breakpoint. Well, it doesn't actually happen because boom. And the reason for this is that during x86-64 bootstrap, the CPU switches from 32-bit mode to 64-bit mode, and that completely confuses this QEMU GDB interaction. GDB, yeah, in Finnish I'd say GDB, so GDB, GDB, ugh, horrible. Saying it too many times just puts my brain in a knot. Yeah, anyway, so this gets, things get confused. So there's a few ways to work around this problem. The first, rather obvious one, is not to use a 64-bit guest but a 32-bit guest, because the 32-bit guest obviously doesn't switch from 32-bit mode to 64-bit mode. This problem doesn't exist there. So if we try that and run GDB again, we put the breakpoint to the main, target remote, and continue. The only real difference in running GDB this way is that you don't run anything because the guest is running. You just continue after you've attached. So it boots and we hit the breakpoint, no problem. Then we can do our usual debugging stuff. Okay. So let's assume for some reason, I don't know, your guest application doesn't support a 32-bit mode anymore. I don't know. I guess it's becoming more common and common, or you just don't want to compile it for 32-bit anymore, or specifically for 32-bit for debugging. So, or let's say the problem you're trying to debug doesn't manifest in 32-bit mode. I mean, that's pretty reasonable. So how can you work around the 64-bit problem? Well, since GDB gets confused when the CPU switches from 32-bit to 64-bit mode, all you have to really do, at least the workaround which I've been using, is attach the debugger after that switch has happened. Now the problem is that if you want to debug something in your program startup, you need to time your attachment quite well. But luckily there's sort of a workaround. So if we write a very simple program, again, I'll just make it print something so you can see what's happening. So we print before, and we print after, and then we put something like a sleep 1 here. The intention, of course, is that this delays the launching of the actual application so that we have a time window during which we attach GDB. So let's compile that. Actually, I need to remember to recompile the hello too, because I think I compiled over it. And let's recompile hello. And so how do we now get these to run in the same guest? Well, I should have mentioned in the previous episode, but if you look, Rumprun bake actually takes multiple input parameters, and this is something we've been toying with. I'm calling it multi-baking, so you can take several applications and bake them into a single guest. And this has a number of quite interesting applications. I won't really go into them now, but it's also useful for this purpose. So let's do it again. First we bake sleep, then we bake hello. And if I just run it here without the pause, you can see what should happen. First it should print before, then wait, and then everything else should blurt out. Now we see before and then okay. So that's our time window during which we need to attach our debugger. Now, of course, it's not too difficult to hit that length of a time window. So yeah, okay, actually we do it like that. We just set up GDB in advance. This is just -ex means that execute this command when GDB runs, and we run it, this, and now we are inside the debugger. You notice we are still in the sleep program because you see before, we don't see after. So now if we put a breakpoint to Rumprun main 2, now you can probably see why the first one is called Rumprun main 1, the second one is Rumprun main 2, because you can't have multiple mains, so Rumpbake just renames these symbols around. We put a breakpoint there, and now we can continue execution. And boom, we hit the breakpoint we wanted, which is at the beginning of the program. Now if I switch to visual mode, which is oh, by the way, this error just means I forgot to add a return 0 at the end of the sleep program, so it just happens to return whatever garbage happens to be in whatever appropriate stack position, I think, on, or is it register on x86 64, I don't remember. But anyway, that's where this error comes from, so it's not an actual error. So if you put return 0 at the end of main, then that disappears. Anyway, yeah, so switch to the text user interface mode, which is Control-X-A. We can see we're in the hello program we wrote, and now we can do just normal debugging. Like I can single step into printf, and you'll notice it goes a bit wonky, but that's just normal because we're libc is compiled with -g-02, and you know, we can single step this as much as we want. And of course, what's really nice about rump kernels in general is that you can almost always single step into the system, or single step into the kernel. But since I don't have time to, or I'm not going to be single stepping all night or stepping otherwise, let's just put a breakpoint and continue running. And you'll notice this is actually the kernel entry point. So I'll switch out of the text user interface mode for a while and print the backtrace, so you can see that we entered Stupid screen corruption. Through the system call. There's a weird protocol for doing system calls, and or a bunch of functions which need to be invoked in order to set all the parameters correct for the system call. And you can see if we scroll down enough, we can actually see here's our main, and it called printf, and then it started going into places. And here, so if we just single step this a while, once it calls this function, which is kind of the back end of the kernel, we should see the hello in the bottom window, and yay, that happened. So, you know, this is really all there is to it for debugging the Rumprun unikernel under GDB. So I hope this episode was useful, and I hope I'll see you for the next one. Have fun. Bye.